Okay, today in Algebra 2, we're going to look at solving systems of equations that have three variables, and we're going to look at two methods. The first method is elimination. To solve a system of equations in three variables, what we're first going to do is use pairs of equations to eliminate one variable from each pair. Make sure that we are eliminating the same variable. When we do that, that will leave us with just two equations with two variables, and then we can solve it using elimination as we usually do with a system of equations. Finally, once I have those two values for two variables, I can substitute the solution back in the original to find the value of the last variable. So let's do an example here. As we look at this system of equations, we see that our y variable would be very easy to eliminate. In fact, if I pair up my first equation with my third equation, multiplying the third equation by 2 would eliminate the y. So let's go ahead and start that and see what happens. We're going to start by using equations 1 and 3 as our first pair. In order to eliminate y, equation number 3 here needs to be multiplied by 2. So let's start with that. We're going to do 2 times 6x minus y plus 4z equals to 2 times negative 1. Distributing gives us 12x minus 2y plus 8z equals negative 2. And we're going to compare that with our first equation of 4x plus 2y plus 3z equal to 1. Adding these together gives us 16x, our y's add to 0, plus 11z equals negative 1. Okay, continuing now that we have 16x plus 11z equals negative 1, now let's take a look at using equation number 2. Again, I want to eliminate the y, so I'm going to pair it up with equation 3 and multiplying equation 3 by negative 3. So negative 3 times 6x minus y plus 4z, and on the other side multiplying by negative 3 times negative 1. Distributing gives us negative 18x plus 3y minus 12z equals 3. And we're going to pair that with equation number 2. Equation number 2 is 2x minus 3y plus 5z equals negative 14. Adding these two together gives us negative 16x, the y's add to 0, minus 7z equals negative 11. I now have two equations with just two variables. If I add those together, I can actually eliminate the x's because I have 16x and negative 16x. So let's do that. Let's put these two equations together. We're going to write 16x plus 11z equals negative 1, and negative 16x minus 7z equals negative 11. We're going to add these together. These add to 0. So 11z minus 7z is 4z equals negative 12. Dividing by 4, z is equal to negative 3. Now that I have what z is equal to, I'm going to substitute that back into one of these other two equations to find the value for x. So I have 16x plus 11 times my value of z of negative 3 equals negative 1. So I have 16x minus 33 equals negative 1. Adding 33 to both sides gives me 16x equals 32. And dividing by 16 gives us x is 2. So now I have both values for x and z. I want to substitute those two values back into one of my original equations to find the value of y. Let's go and let's choose our third equation there. So our third equation is 6x minus y plus 4z equals negative 1. I'm going to replace the x with 2, so I have 6 times 2 minus y plus 4 times our z of negative 3 equals negative 1. So I end up with 12 minus y minus 12 equals negative 1. Well, 12 minus 12 is 0, so I end up with negative y equals negative 1. Dividing by negative 1, y is equal to 1. So I end up with the ordered triple 2, 1, negative 3 in order x, y, and z. Let's take a look at another example of that. In this example, notice that our third equation is already missing z. So let's pair these first two equations and also eliminate z so I could have another equation with just x and y. So adding our first two equations, I have 5x plus y minus z equals 6, and x plus y plus z equals 2. Adding these, I have 6x plus 2y equals 8. Now I can pair it with my third equation, 3x minus y equals negative 4. If I multiply this equation by negative 2, I can eliminate the y's. So let's do that. Negative 2 times equation 3x plus y equals, again multiplying both sides by negative 2, 4 times negative 2. Distributing there, we have negative 6x minus 2y equals negative 8. Pairing it with the equation that we found, 6x plus 2y equals 8. If we add those together, we have something very interesting happen. The x terms add to 0, the y terms add to 0, and on the other side of the equal sign, negative 8 plus 8 is also equal to 0. This statement is always true. When we have a situation that is always true, that means x and y here can be anything at all, and it would make the statement true. So that means that we have infinitely many solutions. If we were to come up with any statement here which was false, like maybe 0 equals 10, for instance, in that case we would have no solution. Now let's look at another method. Let's look at the method of substitution. With substitution, we need to start by solving one of the equations for one of the variables, and we always want to choose the easiest one. So coefficients of 1 or negative 1 on a variable are the ones that are easiest to work with. As I look at these three equations in my system here, I could solve about the same for y, z, or x in my third equation. I'm going to go ahead and choose this first equation, and I'm going to solve it for z. And perhaps the easiest way to do that is to add z to both sides of the equation, moving it to the right. So I have 2x minus y equals z plus 15, and then subtracting 15 from both sides, giving us z equals 2x minus y minus 15. Now we're going to move to step 2. We're going to substitute that into the other two equations. So I am going to replace z in the other two equations. Can't use this one. That's the one I used to solve for z. Has to go into the other two equations. And simplifying those. So equation 2, replacing our z, we're going to have 4x plus 5y plus 2 times the quantity 2x minus y minus 15. That was our value for z. It went in right here, equals 10. Distributing, we have 5x plus 5y plus 4x minus 2y minus 30 equals 10. Combining like terms, 4x plus 4x is 8x, 5y minus 2y is 3y, minus 30 equals 10. Add 30 to both sides gives us 8x plus 3y equals 40. This equation has just the variables x and y. Now let's substitute into our third equation, again replacing our z. So we have negative x minus 4y plus 3 times our value for z, which is right here, 2x minus y minus 15 equals negative 20. Distributing, negative x minus 4y plus 6x minus 3y minus 45 equals negative 20. Combining like terms, we have negative x plus 6x is 5x, negative 4y and negative 3y is negative 7y, and adding 45 to both sides we have equals 25. Now we have two equations with two unknowns. We could solve it by substitution, but solving for x or y leaves us with messy fractions. So now let's switch over instead to elimination. And this is our very familiar system of equations with two variables and two unknowns. We want to figure out which variable to eliminate. I'm looking at the y's. Their common multiple of 3 and 7 is 21. So if I multiply my first equation by 7, and our second equation by 3, we're going to be able to eliminate the y's. So let's do that. Our first equation becomes 56x plus 21y equals 280. Our second equation becomes 18x minus 21y equals 75. Now when I add these two equations together, the y's eliminate, giving us 71x equals 355. Dividing by 71, x is equal to 5. Now that I know x, I can take my value for x, put it back into one of my equations that has just x and y, and solve for my other variable. So I'm going to use 8x, so 8 times 5 plus 3y equals 40. So I end up with 40 plus 3y equals 40. Subtracting 40 from both sides gives us 3y equals 0, or y is 0. And now I want to go back to one of my original equations to find z. My first step that I did in solving with this system was to take the first equation and solve for z. So I've already got a solution for z here. Let's just plug our values in for those variables. So I know that z is equal to 2x minus y minus 15. So let's put our numbers in. Z is equal to 2 times 5 minus y, which is 0, minus 15. Or z is equal to 10 minus 15, which is negative 5. So I have the solution, again, the ordered triple x, y, and z, 5, 0, negative 5. And that's using substitution. Okay, one last thing that we're going to do is we're going to set up an equation or a system of equations to solve a problem. In this problem, we have the marketing department of a company has a budget of $30,000 for advertising. A television ad costs $1,000, a radio ad costs $200, and a newspaper ad costs $500. And the department wants to run 60 ads per month and have as many radio ads as television and newspaper ads combined. How many of each type of ad should the department run each month? In order to define the variables, one of the easiest ways to do that is to see if it works by answering the questions. I'm going to define the variables by telling how many of each type of ad we're going to run. Since I don't know those answers, I'm going to replace that with x. So for TV ads, I have x is the number of TV ads. TV ads, there we go. And I don't know the number of radio ads, so y equals the number of radio ads. And finally, z is the number of newspaper ads. Okay, now I have three equations that I need to write to go with my three variables. My total number of ads is going to give us one of our equations. We have 60 total ads, and all I need to do is add up my number of ads. So x plus y plus z is equal to 60. Now the money I'm going to spend has to add up to $30,000, and I know that a television ad is $1,000. So $1,000 for every x ads is 1,000x. and 200 for radio ads, so 200 times the number of radio ads Y, and newspaper ads 500, so plus 500 times Z, the number of newspaper ads, and that adds up to 30,000. Notice that I've got an awful lot of zeros in here. In fact, I could divide both sides of this equation by 100 to make some of these numbers a little easier to do. For instance, dividing the left side by 100 gives us 10x plus 2y plus 5z, and 30,000 divided by 100 is only 300. This equation is much easier to work with than the equation with all the zeros. We don't have to do it, but it makes our life a little easier. So I have two equations right now, and I need a third one. For my third one, it says we want to run as many radio ads as television and newspaper ads combined. So the number of radio ads, Y, is equal to the combined total of television and newspaper, so X and Z. So Y equals X plus Z. We want to solve this system, and since one of our equations is already solved for the variable Y, let's use substitution. So to do that, let's substitute into our first equation. Let's replace Y with X plus Z. So we have X plus, instead of Y, we have X plus Z equals 60. Combining like terms, 2x plus 2z is equal to 60. And notice, by the way, that all of those terms are even, so I can divide both sides of this equation by 2 to have x plus z is equal to 30. Now let's substitute into the other equations. Again, I'm replacing y with x plus z. So I have 10x plus 2 times my substituted value for y of x plus z plus 5z equals 300. Distribute 10x plus 2x plus 2z plus 5z equals 300. Combine like terms. 12x plus 7z equals 300. And I have an equation in two variables. Okay, I can solve this, continue by substitution, or I can do it by elimination. Let's go ahead and do it by elimination. Let's eliminate the z. If I multiply this first equation by -7, I'm going to be able to eliminate the z. So let's do that. Let's take this equation and multiply it by -7 on both sides. And I end up with -7x minus 7z equals -210. And pairing it with my second equation here, 12x plus 7z equals 300. Adding these together, I get 5x equals 90. Dividing by 5, x is 14. Remember, x stands for the number of TV ads, so we have 14 TV ads. Okay, and let's substitute now this back in into one of the equations with just x and z. You can use this one. So we have 14 plus z equals 30. Subtracting 14 from both sides, z is 16. And z, if we remember, was the number of newspaper ads, so we have 17 newspaper ads. The only thing left to do is find the number of radio ads, and we have that y is equal to x plus z. So y is equal to our x plus our z, so 14 plus 16. Y is equal to 30 radio ads. And that's solving systems of equations with 3 variables.